Good afternoon and welcome back to the online learning platform at Department of Civil Engineering, BMS Institute of Technology and Management, Bangalore. I'm Dr. Rajesh Gopinath and you're along with me for the course Environmental Studies. Friends, in the previous session, we had an understanding of smog, wherein we learned about photochemical smog and coal-induced smog. In today's presentation, we shall try to understand about fluoride problem in the drinking water. In today's presentation, I shall introduce you to the concepts of fluoridation, defluoridation before summarizing and listing the references for your kind perusal. To begin with, let us have some basic information with respect to the presence of fluoride in the natural environment. Fluoride is found naturally in your seawater in a concentration of about 0.8 to 1.4 ppm. If you look at your fresh surface water such as lakes and river, it is usually found in low concentrations, say about less than half a ppm. The highest variable concentration is usually seen in the groundwater, and that can go up to say about 300 ppm. And this is mostly due to the impact or the water rock reactions in your aquifers. Okay, in simple words, due to the weathering action of rocks at great depths, those rocks which contain fluoride. Friends, more than 200 million people around the world, they drink water which have fluoride more than 1.5 ppm. Okay, in fact, if you look at the world map, okay, we have at least 4 fluoride belts, that is wherein the concentration of fluoride is extremely high. One is Japan, second is the Pacific coast of America, then we have the East African Rift Valley, that is stretching from Eritrea to Malawi, and of course we have Turkey to Iran, Iraq, Afghanistan, northern Thailand, China, and yes, our own country, India. So these are the 4 fluoride belts wherein fluoride level is found to be very high. In fact, there is a lake in Kenya, Lake Nakuru, which has the highest measured concentration of fluoride, say about 2800 ppm. So with this basic introduction to the concentration or availability of fluoride in the natural environment, let us now move on to its historical importance. Okay, much before we understood that too much of fluoride is bad for the health. Okay, fluoride actually was found to be significant also in improving the health of a human being. In fact, this has been considered as one among the 10 greatest public health achievements of the 20th century. Friends, I'm talking about artificial water fluoridation. This clinical discovery was made by Frederick S. Mackay. He was a dentist, okay, representing Colorado Springs, wherein he was able to understand that there was some form of connection which existed between fluoride and the health of the teeth. I am talking about, the hypomineralization of the tooth, or in simple words, mottled teeth, that is stains on the teeth. Okay, beginning in 1901, Mackay actually gave systematic attention to the brown stains he found on the teeth of many of his patients, and he had finally hypothesized that it is due to the water supply. Okay. Further, in 1909, Mackay joined hands with Dr. G.V. Black, and they discovered that fluoride is also connected with the prevention of dental caries. Okay, so friends, in simple words, what I'm trying to express to you is it was understood that when the fluoride level is less in the human body, okay, when the fluoride level is less in the drinking water, it led to a medical condition called as dental caries, okay, which is often associated with hypomineralization, okay, or brown stains on the teeth. Now, this discovery that fluoride is important for good health of the teeth is considered to be the greatest public achievement. In fact, after this discovery was made, okay, a series of studies were carried out to understand how much of fluoride needs to be provided for making sure that the tooth doesn't undergo any form of decay, or in other words, dental caries. There was a three-arm trial which was carried out on three cities. One was the Aurora, Muskegon, and the Grand Rapids. Grand Rapids actually was an experimental town wherein fluoride was intentionally added for 1 ppm. Muskegon was a controlled setup, no fluoride was added in that, and Aurora was a town which had naturally fluoridated water about 1.4 ppm. So based on these experiments, they were able to understand that, dental caries in the experimental town was similar to that in the naturally fluoridated town. Okay, dental caries in 6-year-olds in the experimental town was actually half of that of the controlled town. So it was hence deduced and understood that fluoride concentration is important and significant in order to ensure that tooth decay doesn't happen. Okay, Grand Rapids in Michigan was the first city which received fluoridated water. That is, I'm talking about artificial water fluoridation. But friends, since then, okay, there has been a reversal of trend wherein if the cities wanted to get their water supply fluoridated, after a few decades, the reverse trend happened, wherein they understood that too much of fluoride is actually bad for the human health, and then the reverse engineering happened, wherein they started defluoridizing the water supply. In fact, the Scottish town of Wick, okay, they started defluoridizing their water by 1979. In fact, a town like Kilmarnock, which actually started fluoridizing in 1956, they started stopping it in 1962. Okay, these are based on the observations and studies which were carried out on the people who had depended on the public water supply. Okay, as the basic supplement. Now, with this basic information, wherein we have deduced the following facts, that is, fluoride is naturally present across many different water sources, some low, some moderate, and some very high. Also, we understood that artificial water fluoridation was intentionally carried out because the scientists, the doctors were able to deduce that lack of fluoride in the drinking water and the human body led to tooth decay. Further, finally, closer to the 2000s, okay, that is after 1960s, 1970s, doctors were also able to deduce that excess of fluoride was actually causing more damage than the lack of fluoride itself. So you can understand from this very slide that fluoride had a historical evolution from its discovery to its importance in water supply to the necessity of removing excess fluoride from water supply. Okay, now let's move further. Why exactly do we need fluoride in the drinking water? Friends, basically, when you speak about tooth decay, okay, tooth decay is something which happens across individuals of all ages. That is, some people you say, we are suffering from cavities, some people say tooth decay. So what exactly is the difference between these? It all depends on the terminology that has been used. Okay, so basically the practitioners in the medical field, in the dental field, they tend to use the technical terminologies, okay, while layman such as us, we tend to go for terminologies such as tooth decay. If you look at the image on your right hand side, it's a comparison of your healthy tooth with a tooth which has been affected by tooth decay, okay, in the initial stages, which is called as caries. Now, when the tooth decay becomes excess, then it is called as cavities, or also it is called as deep caries. Friends, basically what you see, the image on the bottom right hand corner is a comparison of a healthy tooth and a tooth which has been impacted due to dental caries. So basically you can see that there are brown stains, and basically there are also pit in the enamel. So if you are looking at the image on the left hand side, basically what we are seeing is we are seeing the various stages of dental caries development, that is from a healthy tooth to a severely damaged tooth. So are dental caries and cavity the same thing? Yes, both are the same thing. It only depends on how we use the terminologies. Okay, now let me also try to explain to you what is the importance of having fluoride in the drinking water. Why is that the doctors in Colorado Spring, okay, why is that Frederick S. McKay, Dr. G.V. Black, why is that they emphasize that fluoride must be present in drinking water to avoid dental caries? Let me try to explain that aspect to you. Friends, let's try to understand this with a simple example. Okay, coming to the biology classes, we have all learned that the pH of our mouth is around 7.4. We also know that when we eat food, when we eat sweets, okay, when we eat sugary drinks, okay, for that matter anything, we tend to chew the food, and when we are chewing the food, there is mixing of saliva with the food. There is action of the enzyme salivary amylase which happens on the food, especially when I and you, when we eat sweets, okay, the products would be sucrose, that is glucose, in simple words sugar, and acids. So friends, I would repeat this: when we eat food, when we chew the food, when there is saliva mixing with it, when salivary amylase acts upon the food, the products would be sucrose and acids. Okay, now we are not talking about the concept of sucrose production which is connected with your diabetes. Okay, we're talking about the acid production. We know very well that when acids are produced, okay, the pH would automatically drop down. We also know mutually that more than 1 up to 7 is considered acidic range, greater than 7 up to 14 is alkaline range, and 7 is actually the neutral range. Friends, the tooth, okay, is basically a very strong chemical compound called as hydroxypeptide, an extremely stable compound which can withstand any pH changes as long as it is more than 5.7. So we know very well that the pH of the mouth is 7.4. So as long as the pH is maintained above 5.7, there's nothing to worry. The problem happens when the pH of the mouth falls down. So if we are on an exercise of eating more of sugary items, sweet items, okay, or let's say any kind of drink such as Coke or Pepsi, anything which has more of sweet content, okay, or let's say ice creams and chocolates. So what happens is there is more production of sucrose and acids. When there is more production of acids, what will happen? The pH of the mouth will drop. So once the pH of the mouth drops below 5.7, that is when the problem starts. At a pH below 5.7, the chemical compound hydroxypeptide, which is your teeth, okay, will start breaking down. All the hydroxyl ions of hydroxypeptide will dissolve in the acids. Okay, this is when the damage initiates. This is when the damage starts. Okay, and when the pH again further falls down, your teeth actually starts breaking down in the form of stains and pit in the enamel. Okay, so friends, this is actually the medical condition which is called as dental caries. That is when the pH falls below 5.7 and the tooth has a breakdown. But you might be curious and you might ask me, what is the connection of fluoride with this? Because it was said that fluoride, if it is less, then there is a medical condition called as dental caries. Okay, now let me re-express. Friends, at the point of time when the pH falls below 5.7, when all the hydroxyl ions got destroyed, if the human body, or if we drink water, or if our food has sufficient fluoride of say about 1 ppm, then what happens is this fluoride will go and settle on, or rather I would say this fluoride will go and replace the active sites wherein once upon a time hydroxyl ions were present. So once fluoride goes and occupies those active sites, the tooth decay will stop, because when fluoride goes and occupies those active sites, it becomes a new chemical compound called as fluoropeptide. Okay, now fluoropeptide is much more stronger and stable than hydroxypeptide and can withstand a pH, okay, up to 4.7. So even if the pH falls below 5.7, as long as it is above 4.7, your tooth is safe. And then naturally over a period of time, the hydroxyl ions are generated, which replaces the fluoride. So to summarize, I would say it in simple words that dental caries is not a medical condition which is caused due to lack of fluoride. Dental caries is rather a medical condition which is aggravated due to lack of fluoride. Had fluoride been available in the human body or in our food or in our drinking water, okay, to a suitable level, that fluoride would have arrested the tooth decay. Okay, friends, with this understanding, let me tell you that in the drinking water, the fluoride level must be at least 0.75 ppm to about 1.5 ppm. Okay, below 0.75 ppm, the cases of dental caries would aggravate. Now, how do we go about ensuring that we have fluoride in our drinking water or our supplement? Basically, what we need to understand is, in 1984, World Health Organization itself had issued guidelines on water fluoridation. Friends, now when you speak about guidelines, okay, here the guidelines are based on temperature. That is, countries which belong to the warmer regime and countries which belong to the colder regime. And that's because, people in the warm countries would tend to drink more water, and that would eventually cause more issues with respect to dental caries. Nevertheless, the upper limit is always 1.5 ppm. So remember, if your fluoride level is less than 0.75 ppm, you will have a medical condition called as dental caries. So always it's better that the fluoride level is maintained between 0.75 to 1.5 ppm. How can we do it? There are two ways of going about. Okay, one is systemic and the other is topical. Okay, systemic includes examples such as water fluoridation, okay, maybe school water fluoridation, milk fluoridation, okay, fluoride drops. Now, topical would actually have examples, with respect to professional application and self application. In simple words, friends, uh, systemic is when fluoride is ingested in a small amount during the tooth formation in the jaw, and this gets built into the enamel. Okay, so we are talking about an age that is, probably from 6 months to 6 years. While topical, on the other hand, is wherein you try to prevent, okay, the bacterial activity in the mouth. You try to build a stronger cavity resistant outer surface, okay, wherein you tend to use probably mouth rinsers, okay, which is rich in fluorides. Okay, so systemic is something which is applied at a very tender young age to make sure that dental caries doesn't happen, and topical is wherein you tend to apply fluoride to make sure that the tooth remains healthy without any decay for a lifetime. All right, now let us try to understand what are the advantages of having fluoridation. Simple. If you have fluoridation which is done systematically, then that means that, you prevent tooth decay. And when I'm talking about tooth decay, I'm talking about protection of individuals of all ages from having cavities. Obviously, you save money, okay, you save productive hours. These are benefits which are not only health wise but also economical, and they last a lifetime. And yes, aesthetically, you have a good appearance of the tooth. Please understand, friends, wherever fluoridation had happened, the chances of dental caries was found to be very less. That is the information that you can see on the chart in front of you. But this is where we need to understand the other side of the story. Okay, now when fluoride level was very less, it led to tooth decay, it aggravated dental caries. But when the fluoride level was very high, this also led to one more problem, the problem of fluorosis. Okay, but before we move into that, let us have a quick glimpse of how, fluoridation can happen. So friends, fluoride can be added to your milk, your school water, or your drinking water by adding some chemicals such as sodium fluoride or fluorspar, silicofluoride, and so forth. There are various equipments. As you can see the dry feeder. Your other equipments also, such as saturator system or solution feeder system. However, having said all this, there are certain criteria that we need to understand to decide the fluoridation aspect. Okay, first and foremost, there must be a municipal water supply which is reaching a reasonable number of houses. Okay, that means there are several people, several houses who depend on the water supply supplied by a municipality. Okay, if that is the case, then it is worth doing fluoridation, because fluoridation is an economical exercise. There is some amount of economy involved, there is some amount of investment involved. If a municipality wherein there are people depending on private wells and bore wells, okay, or rainwater or tankers, then there is no use of fluoridizing your water. Okay, it would absolutely make no sense. Okay, so there is an economical connection when it comes to fluoridation of your drinking water. Okay, now let's now move on to what I was talking before, that is the problem of excess fluoride, in other words fluorosis. Friends, before I comment upon this, let's have a quick recap. Remember this: less than 0.75 ppm, the medical condition is called dental caries. Okay, we need to make sure that the body always has, or your drinking water has, or any supplement for that matter should be able to support, wherein there is at least fluoride presence from between 0.75 ppm to 1.5 ppm. Okay, now if in case the fluoride presence is more than 1.5 ppm and up to 2 ppm, then there is a disease which is called dental fluorosis. Okay, if the fluoride level is more than 2 ppm and up to 4 ppm, then there's a disease called as skeletal fluorosis. If in case the fluoride level is much higher than 4 ppm, then it means non-skeletal fluorosis, which eventually speaks about manifestations in the neurological system, muscular system, your gastrointestinal system. In other words, I'm talking about multiple organ failures and ultimately death. Okay, so excess of fluoride is also bad news. And why is this excess of fluorides happening? Probably because the population is depending more upon groundwater, okay, which has excess of fluorides due to weathering action of rocks at greater depth. Also, it's possible that due to certain industrial emissions, such as your aluminium processing industries, you know very well that industries which extract aluminium, they work upon bauxite, the natural aluminium ore, that is Na2Al F6. So these industries, when they work upon bauxite, they do it at very high temperatures. At these high temperatures, the entire bauxite is melted, and at this time fluoride escapes into the atmosphere as a gas, and this fluoride can go about dissolving in rivers or any other natural environment. So friends, there are both natural sources and artificial sources of how fluoride can get enriched, okay, in the natural environment. In fact, in India, okay, the fluoride level being very high was first observed in the Indian scenario in Andhra Pradesh in the 1930s. Okay, and I'm talking about the context of dental fluorosis, skeletal fluorosis, and non-skeletal fluorosis. Friends, when I say non-skeletal fluorosis, I'm talking about muscular weakness, muscular stiffness, okay, loss of muscle power, nervousness, depression, consistent abdominal pain, blood in the stool, and so forth. Okay, now moving forward, let's try to understand about dental fluorosis. Friends, dental fluorosis, medically, if I say, I can say that it is the hypoplasia of the dental enamel resulting from the prolonged ingestion of drinking water which contains very high level of fluoride. And this is manifested by the condition called as mottled enamel. In simple words, dental fluorosis is a condition wherein the fluoride level being more than 1.5 ppm in the food or the water results in stains and pit in the enamel. As you can see on the screen, from a healthy tooth to mild fluorosis to a moderately severe and extremely severe, how the appearance is impacted, how the strength is impacted. Okay, now please understand that if in case there is a patient who is suffering from dental fluorosis, then there are very rare less chances that he or she will be susceptible to dental caries, because these are extreme situations. Okay, also please understand that the severity of fluorosis actually depends on the amount of excess fluoride which has been consumed over a period of time when the teeth was actually developing. That is, I'm talking about the age group from 6 months to 6 years. So this is a sensitive period during which excess fluoride causes damage. Friends, actually, when you drink water, you brush your teeth or you eat food, and when there is fluoride present in that, the fluoride actually goes and gets deposited on the tooth and the bones, okay, not any other part of the body. All right. Now, please remember, once the teeth have erupted, fluorosis cannot develop. So it is that tender age of 6 months to 6 years wherein we need to be very careful. Okay. Now, mild fluorosis, as you can see in the image, the mildest form, wherein fluorosis appears as opaque white patches on the enamel. Okay, you can see here the white patches, the white opaque patches. Now, moderately, severe fluorosis is basically brown, discolored, mottled enamel. Okay, now if you look at the extremely severe fluorosis, then we are basically talking about discoloration. So from opaque white, it turned brown and it is turned here dark. Okay, and also we can see that there are several pits in the enamel. Okay, so these are the symptoms and causes with respect to dental fluorosis. Okay, in fact, 1931 itself, Mackay was notified that high levels of water fluoride was actually causing discoloration of tooth enamel. Okay, now let's try to understand about skeletal fluorosis. Friends, skeletal fluorosis is the condition wherein when the concentration of fluoride exceeds more than 2 to 4 ppm. Basically what happens is it results in a medical condition when it becomes very difficult for individuals to walk or hold things. Basically it affects your uh, you know your connections between the bones. Okay, now uh, we know very well, now if you're able to walk, okay, if you're able to hold things, it's because of your joints. Now if in case your joints get locked up, if in case there is calcification which takes place, then it eventually makes sure that these functions are impaired. In fact, the early stages of skeletal fluorosis, they start with pain in bones and joints, muscular weakness, stiffness of joints, of course, and chronic fatigue. But during the later stages, calcification starts taking place. Osteoporosis actually in the longer bones. Okay, so finally, what happens? Your bones actually become very dense and they develop abnormal crystalline structure. Friends, as you can see on the image here, eventually they get deformed. Okay, they become denser and develop into abnormal crystalline structure. Okay, this form of skeletal fluorosis, or let us say, look at this unfortunate incident of a child. Okay, look at the deformation of his legs. Friends, crippling skeletal fluorosis will occur in people who have ingested at least 10 to 20 milligrams of fluoride per day for at least 10 to 20 years. Okay, so it's a very severe problem. In fact, skeletal fluorosis has 5 stages: a preclinical 1, preclinical 2, stage 1, stage 2, stage 3. Stage 3 is wherein the crippling effects take place. Stage 3 is wherein deformities start. Stage 3 is wherein actually you have a hunchback and you have spinal immobility. Okay, so it's a very unfortunate thing. So when it is unfortunate, it is very imperative that we need to remove the excess fluoride which is present in the water supply, probably due to artificial causes, due to natural causes, due to a very bad design. So this is what we call as defluoridation. Okay, now why do we need to do defluoridation? So that we can avoid the incidence of fluorosis, that could be dental, skeletal, or non-skeletal. Now what we need to understand here is, though there are several methods, technologies for defluoridation, most of these are not, uh, dedicated or sincerely only for the removal of fluorides. For example, if you're talking about reverse osmosis or distillation or electrodialysis, okay, or if you're talking about agents such as bone charcoal, calcium phosphate, activated carbon, see, these are capable of removing any anion or cation for that matter. So the advantages, fluoride is one among them. So what I'm trying to stress is, we do not have that one dedicated technology which is meant only for removing fluorides. Okay, and even if we have, they are very less, very few, and probably not very efficient as well. Okay, now as of now, the various techniques which are available to remove fluoride includes adsorption, okay, wherein you employ activated carbon. Okay, you also have ion exchange. Okay, you also have something called as electrochemical defluoridation, reverse osmosis, but probably in today's class we'll be focusing more on Nalgonda technique, which is basically a precipitation technique. Friends, all techniques have their merits and demerits, okay, but mostly the challenges which have been observed are with respect to the initial investment cost, okay, the regeneration cost, the removal efficiency, the difficulty in maintenance and operation, and of course sometimes your technology is only removing the fluoride from the water and transferring it into another state, probably a solid state, which means there is excess production of sludge. Okay, let's move further. Now, when you speak about defluoridation by activated alumina, this is a technology which was introduced by the UNICEF. Okay, now here what happens is it's an expensive technology, but yes, it has very high selectivity when it comes to fluoride removal. But please understand that this requires very high temperature range for operation, stretching up to 600 degrees Celsius. Okay, in fact, I'll be very happy to share that the application of domestic defluoridation plant, which is based on activated alumina, was launched by UNICEF for rural India itself. Okay, but unfortunately, due to the cost, which is because of frequent activation of alumina, this technology is not that effective. Okay, you also need to understand it is pH specific, which means that the water which is being passed through the system, you need to make pH adjustments, pre and post pH adjustments. Okay, now let's talk about the next one. We are talking about defluoridation by bone char. Friends, this is the oldest available technology and it is still being practiced in places such as Africa. Okay, now basically what happens here is, though there is a great efficiency of 66% removal, wherein animal bones are actually being used, okay, to remove the fluoride. That is, in simple words, bone char which is produced with animal bones that have actually passed through calcination process, okay, these are employed to remove the fluoride from the drinking water. Okay, now the only issue is when you're talking about this kind of technique, bone char itself may harbor bacteria. Okay, and this is a technique which is very sensitive with respect to procedures, and probably there is a question of hygiene involved, and yes, there are definitely a lot of objections, because you're talking about objections from cultural side and religious side, because you're actually using animal bone to purify your drinking water. Friends, reverse osmosis is also one more technology wherein we can remove excess of fluoride, and in simple words, we can say that when you apply excess pressure on the water as it passes through a semi-permeable membrane, the water gets passed while the salts or the fluoride is retained behind. In fact, most of us tend to have this kind of technology in our houses also when we speak about water filter. Okay, now let's try to move on and understand something about defluoridation by Nalgonda technique. Friends, Nalgonda is a place in India. This technique was developed by NEERI, that is National Environmental Engineering Research Institute. It is located in Nagpur. Okay, now Nalgonda technique is a very famous technique and it always refers to fluoride removal. Basically, what happens here is you're talking about a systemic addition of sodium aluminate, that is filter alum, okay, then bleaching powder, okay, and then lime. So basically, you're talking about a process wherein you are able to remove fluoride irrespective of whether it's a domestic supply or a community water supply. Okay, Nalgonda technique is actually a combination of several unit operations and processes. See, it involves rapid mixing, chemical interaction, flocculation, sedimentation, filtration, disinfection. Okay, so it's a sequence, it's a combination, and the best advantage is this can be employed irrespective of the quantity of water which has to be defluoridized. Okay, it's also economical. The cost is very low when it comes to investment, when it comes to its operation, when it comes to its maintenance. The only disadvantage is if in case the water supply is already highly saline, then it will interfere in fluoride removal. Also, the end product of this treatment would be a very high quantity of sludge. Okay, when you compare to processes such as reverse osmosis or electrochemical defluoridation, here the sludge produced is very high. Okay, now if in case your water has very high total dissolved solids, let us say talking about seawater, okay, if it exceeds more than 1500 milligrams per liter, then the water has to be subjected to desalinization first. Only after then you can go about defluoridation. So, friends, what is that we have learned today? We understood about the evolution of the significance of fluoride in drinking water with respect to fluoridation, and then data with respect to defluoridation. We also had a brief understanding of how fluoride is added to water, how fluoride can be removed from the water. I'm talking about excess fluoride in the latter case. We also understood the issues with respect to dental caries, dental fluorosis, skeletal fluorosis, and non-skeletal fluorosis. Towards the end, we have understood something about Nalbonta technique, which is very popular and most preferred over any other technologies which is existing in this country when it comes to removal of excess fluoride. So friends, these are the references which I've listed for your kind perusal. Those references which are listed from 13 to 17 are more specific with respect to this concept, and I would request you all to go through this to enhance your understanding. You're always welcome to go through any kind of material to improve your knowledge. Okay, in the subsequent class, my dear friends, we shall be understanding about environmental pollution and abatement in the context of water pollution. Of course, we shall be understanding it with the help of case studies. As you can see, the image on the left hand side is the problem with respect to your Belandur Lake in Bangalore, and the image on the right hand side is with respect to the Minamata Bay disaster due to mercury. Okay, so friends, I thank you for your kind patience in hearing, and now the platform is open for any questions, any queries that you might have.